So today we're going to look at solving a system of equations by graphing. So we'll start with a definition of system of equations. A system of equations is when you have two or more equations that has an x and a y in it. So here's our steps for graphing. Our first step we'll have to get our equations into slope-intercept form. So y equals mx plus b. Then we will graph from that step. Once we have our graph of our two lines, our solution or our answer is going to be where those two lines intersect. So we're going to look at a couple examples. We have these two equations. Both of them are already in slope-intercept form, so we can just graph both of them. So I've done that here. Here is my y equals x plus 3. Notice I start at y equals 3. And then my slope is 1, so I go up 1 over 1, up 1 over 1. I can also go down 1 and to the left, down 1 and to the left. Okay, to graph y equals 2x plus 1, I start at my y-intercept, so 1, and then I go up 2 over 1, up 1, 2 over 1. So you see these lines do intersect, so our solution is going to be that intersection point, which if you look, we go over 2 and then up 5. So our solution is 2, 5. Now you can always check your answer by plugging that xy coordinate point into your two equations. So I did that below here real small. If you plug 2, 5 in for both the 2 for x and the 5 for y, you get, does 5 equal 2 plus 3. 2 plus 3 is 5. So this coordinate point works in the first equation, and now we check it in the second equation. So again, I plug 2 in for x and 5 in for y. 2 times 2 gives me 4, plus 1 is 5, which is our y value. So now if you go and look at your foldable that we have, our first page is solving by graphing. So we're going to look at this top example. Notice that our top equation is in slope-intercept, however, our bottom equation is not. So I can graph y equals x plus 2 right away. So I go over to 2, and then my slope is positive 1. So I go up 1 to the right, up 1 to the right, up 1 to the right. Okay, or down 1 to the left, down and to the left. To get my second equation into slope-intercept form, I need to take this negative 3x and move it to the other side by adding 3x. So if I add 3x to the other side, I get y equals 3x minus 2. So here, I'm going to start at negative 2 and then go up 3 over 1, up 3 over 1. We get our lines to intersect at the point 2, 4. So our solution to this set of equations, or this system of equations, is 2, 4. Okay, this system of equations, neither one are in slope-intercept form. So I take the top equation and I set it equal, or excuse me, I'm solving for y. So I'm going to subtract my x to the right side. And then this is a negative y, so I divide by negative 1. So I get y equals positive x minus 5. And then that graph starts down here at negative 5. My slope is positive 1. So again, we're going up 1 to the right, up 1 to the right, up 1 to the right, up 1 to the right. Okay, this equation, I need to get that 3x to the left side, or excuse me, to the right side. So I subtract 3x and I get y equals negative 3x plus 3. So here we're starting at positive 3. Our slope is a negative 3 over 1. So we're going down 3 to the right 1, down 3 to the right 1. Again, to get our answer, we look, where do those lines cross one another? And they cross at 2, negative 3.